Thank you for joining us today. Welcome to Systems Thinking Introduction Presentation and Workshop. This is part of the learning series, the 10-week learning series that started during the first week of March and will go on until the first week of May. And the session is hosted by the SI Network core team. My name is Roma Patadia. I'm joining from Bangalore. And I work as program manager and innovation facilitator at the SI Network. We have Joss Colchester joining me today. He is the founder of the SI Network and also works as ecosystem builder, joining us from Barcelona. And we're really excited to host today's learning series session. For those who are new to the learning series, we have this 10-week learning journey along with the cohort. So every 2 weeks, we cover one module. And for instance, every even week, we have the kickoff session. We discuss different concepts. And every odd week, we have a learning cohort meetup where we can meet together and discuss whatever we have learned in the previous kickoff session. This is also pathway to certification. If you're interested in level 1 certification for systems innovation, you could click here and find out more about it. And this particular session is about systems thinking, which has 5 different parts to it. And if you click over here, it'll take you to the syllabus on website. And you might have to also subscribe to the learning content in order to access the learning material and get the certification. And the session will go on for about 90 minutes. It's interactive. So at some point, we will all hop onto the Miro board and have interactive session. And the session is being recorded. In case you have missed any part of it, we will share it on the website towards the end. And then today we're going to learn about systems thinking better. We'll get hands-on experience with some of our tools. And it's going to be a 10-week long journey. And we are in the 3rd week. So for the icebreaker, I'm sharing the Miro board link in chat box. Feel free to hop in and let us know what is your level of understanding of systems thinking. Feel free to pick one of these dots and place it on the horizontal bar between I'm a curious newbie to I'm a systems thinking pro, and let us know your experience. I think Joss has already shared the Miro board link over here. And all right, so we have beginners. We have people who know quite a bit about it. Yeah. So once you're done with that, you could also share your LinkedIn profile in one of these sticky notes below the icebreaker, so that the rest of the team learning cohort members can reach out to you and connect with each other. So feel free right after you're done placing the dot on the horizontal bar. Awesome. I think it's good time to move on to the next part. I'd like to invite Joss to take us through the workshop and the presentation. Over to you, Joss.
Excellent. Good to see everyone here today. And welcome back for a lively conversation around systems thinking, what it is and why it matters. Going to have this presentation here and some questions and interactivity on board, and then there's going to be a workshop afterwards. I'm going to jump in to try and make the best use of our time. We're learning about this idea of systems thinking in the context of the broader program around systems innovation. So this is very important in that broader context as the foundations for innovation, right? Innovation is about the application of new ideas towards changing established ways of doing things. And if we aren't thinking systemically, if we aren't bringing in new ways of looking at the world and new ways of understanding complex systems, it's unlikely we're going to be really innovating on that level. So that's why we start here. And really try and help you, understand these ideas. And hopefully today you see the potential and power and ability of these ideas to really transform our way of looking at the world, and then from that new kind of insight into the way systems work around us and the systems we form part of, we can really start to innovate and create systems that hopefully work and work for everyone. So let's jump in then. Peter Senge, from his book, The Fifth Discipline, said that systems thinking is a discipline for seeing wholes. It's a framework for seeing into relationships rather than things, for seeing patterns of change rather than static snapshots. And today it's needed more than ever because we're becoming overwhelmed by complexity. So you'll often hear this association between complexity and systems thinking. And complexity or systems thinking really helps us approach the complexity of the systems in our worlds and not, as he says there, get overwhelmed by them. And hopefully that will become apparent as we go through and, why that's the case, and how it's really going to help us better understand complex systems. And there's lots of different ways of approaching, systems thinking and how to present that. This is how I like to frame it on a very high level, that it helps us see systems in some sense, not just the individual parts of those systems, but it helps us see the forest, which is the whole, rather than just a set of trees. So a system is a set of parts that are interrelated in forming some overall pattern of organization that fulfills some function within an environment. And that's the model of a system. And systems thinking is going to try and help us see that and understand that, because we don't always really see the world like that. Sometimes we just see it as a set of parts, and we miss out on the relationships that integrate it into the whole system. And we don't really see the forest. We get caught up in all of the trees. And we're trying to elevate our thinking to some sense to see how those trees interrelate and form this overall ecosystem with all these diverse and different creatures interacting and interrelating. And that is one way of approaching systems thinking. It helps us see the forest instead of getting all caught up in the trees. Hopefully that makes sense. In some ways, that's very simple, right? It's really a sense-making tool, right? It's a way of kind of framing what we're doing here on a very high level. And it's a very important kind of shift to help us move from this focus on individual parts and trying to improve those to stepping back and looking more broadly at the overall network of interrelated parts that form a whole system. And that's what systems thinking is trying to do, is trying to help us balance this more linear or analytical view of the world with this more holistic view. And we'll talk about what we mean by that in a minute. And in that sense, it's not a tool, it's not an idea, it's a paradigm, it's a worldview, it's a way of looking at the world. In some sense, it's a culture, right? And it's a worldview that's going to help us better understand complex systems and then innovate in them. So that's where we're starting. We're not going to end there because that wouldn't be super helpful, right? It would leave you kind of floating up in the air. To bring this down to ground, we try to explore that from different perspectives and try and create something of a contrast between this analytical mode of thinking and this more holistic way of thinking. This graphic here tries to do that along 4 dimensions that we're going to be exploring today. On the left is this more analytical reductionist view, and on the right is this more holistic view. And in each case, we're trying to understand what the world looks like from each of these perspectives. What does it look like when I just kind of look at the parts? What does it look like when I try to look at the whole? What does it look like when I what does the world look like when I use these glasses, these goggles of reductionism and try and break everything down? What does it look like when I look at the world in terms of emergence? So hopefully you're getting this idea of kind of glasses that you put on. None of this is really right or wrong or true or false or anything like that. It's a choice about the way we look at the world. It's a choice about the way we choose to categorize the world and um, how that helps us or hinders us, right? Reductionism and holism, neither of these are right or wrong. They're just ways of looking at the world. It's like asking, is it better to eat your dinner with a spoon or a fork? Well, they're both right or wrong depending on what you're trying to eat, right? So the same here. And if we understand how to use a spoon and a fork, then we can use both depending on the situation. So we're trying to improve our thinking, understand these paradigms so that we can adopt the right one in the right situation. So we're going to look across these four dimensions, and I'm going to explain, some of those words I used there that you may not yet understand, reductionism or emergence, things like this. Um, so we look at those top two first, and then we're going to talk about this, relational or networked view of the world, and then we're going to talk about, non-linearity and so forth. So that's what we're covering today. It's this board here, and let's start at the top left here. So core to really making sense of systems thinking is helping you understand the distinction between reductionism and holism. And they can also be thought about in terms of analysis. Analysis is a way of understanding the world. It's analytical reductionism, they go hand in hand, and holistic synthesis. So I'll explain what I mean by those, but you can see here analysis or reductionism is breaking things down and trying to understand. Both of these are trying to understand the world. They're ways of us going about inquiring about how does the world work, what's going on, how do we understand the systems and things around us. Reductionism, analytical reductionism, breaks them down. It creates an account of systems by looking at their individual parts, taking the thing apart, understanding the parts, and then assuming that the whole is just a combination of those parts. So a bicycle, you can understand it like that. You take it into your garage, you take it apart, and you study all those parts, and then the whole bicycle is nothing more than the sum of those parts. And that's reductionism. But there's another way of looking at this bicycle, because a bicycle is not just a thing that sits in your garage all day. There is, of course, a purpose to this thing. It has a function. And when we think about it in the context of its function, it exists out there in the world in relation to other things. It doesn't exist just for the sake of being a bicycle. It exists for the sake of moving people around, mobility, personal mobility. So it exists in the context of a person who wants to move around. It exists in the context of a transport system, a road, a cycle lane. It exists in the context of maybe a city or a pathway, and it exists in a whole context, right, of all the other things it interacts with. It exists in the context of commerce. Someone buys this bike, someone sells it, and someone has to repair it, and so forth. And that's another way of looking at systems. And in that approach, we're actually looking upwards and outwards at the whole forest, should we say, the big system that this bicycle forms part of. And that's holism in the sense that holism always says everything exists in a broader context, and we can only understand it in relation to that broader system it forms part of. We're never going to figure out why a bicycle exists or what it really does without putting it into its broader context of people cycling around. So that's what holism always does. And analysis always does the opposite. It takes it apart. It says, I want to understand this thing, so I'm going to take it apart. Give a child a toy, and they will try and take it apart because they want to understand the world. And that's one way of understanding the world. And that's pretty dominant, this analytical reductionist approach in our world. It's really came a powerful force in modern society with the rise of modern science 500 years ago, and we've applied it in every context, how we manage organizations, how we do food systems, so on, health, and so forth. And we've fully kind of fleshed out those systems according to analytical reductionism, and that's created a lot of benefits in the world. It's also created a lot of challenges for us because we end up dividing things up and separating them out, and we create a lot of silos and a lot of disconnected systems. And systems thinking is saying neither of these is right or wrong. We need both of them. And we need to balance both of them. If we really want to understand this bicycle, you can't just take it apart. You have to go put it out there in the world and cycle it around and see why it exists in that context and how it interacts with all these other systems. And when we understand both of those, then we're really going to understand this bicycle. And that's kind of the foundational, point of systems thinking. Don't just help me understand the tree or the next tree or the next tree. Help me understand the whole forest. And one is going to zoom in on the tree, and the other is going to step back and try and help us understand the whole forest. Is that clear to people? What do you think about that? Any ideas? Is that what you expected systems thinking to be, or do you think I'm missing something there? Gemma, any ideas? What do you think about this? Catherine, would you like to share anything? Does this make sense to you?
Am I the Catherine?
You're the Catherine. Yep.
It resonates. In some way, I kind of was sitting here thinking, and I've done some of this work before, it's almost amazing and alarming to me that people don't automatically have this mindset shift. Like in the world we live in now, the complexity, you almost cannot believe almost. Once you kind of see it, you can't unsee it. And therefore you, in a slightly irritating way, you can't believe that people are not already there. So I was sitting here kind of going, that's a bit depressing. It feels like there's a long way that we have to go.
Mm. Yeah, very true. Mark?
Yeah, I thought I'd just chime in that either controversially or not, it really reminds me of what used to be called left brain, right brain thinking, for starters, and that hemisphere, but then also the Enlightenment and Romanticism, as those two big bits of philosophy, the way they worked. Yeah.
Yeah,
It's
I mean,
quite ephemeral.
this has always been there, right? If you went back to the Greek philosophy, I'm sure we'd find it there, and throughout history, because it is, as you say, kind of left brain, right brain, or alternative culture, mainstream culture. We'll see it throughout kind of history. I mean, it's always there. So, not surprising. Anyone else? Mike? Yeah.
Yeah, I mean, I've done quite a bit already on this kind of stuff. I read the Grammar of Systems Thinking book a couple of years ago, which was really good. But yeah, the thing about just like responding to what Catherine was saying about there is a thing of like how looking at things in systems, but it's so easy to just go back to thinking and seeing everything as things and everything is fixed. It's so like I catch myself doing it all the time, when you kind of talking about someone as being like this fixed thing and not looking at the relationships around it. So I think we're so used to thinking in that reductionist kind of way that we sometimes don't even realize how much we're doing it. It's been my experience because I have to keep doing it. No, I'm not looking, I'm not thinking like that. Thinking like this. Whoops.
Well, almost the most important thing, Mike, is the awareness around it, isn't it? That you are aware, because most of us aren't aware that of that, and when you are, then you can try and proactively work on elevating your thinking, which is, I think, the best we can do, right? This is an exercise. It's not like someone teaches you system thinking in 90 minutes and then you're done for the rest of your life. It's like it's an exercise we're going to be working on all the time, but the key part is just this basic awareness of, and to stay being reflexive about how I look at the world. Reflexivity is an important part of it. Okay,
it's like a discipline.
Exactly, it is a discipline, right? The fifth discipline is the name of the book, as Peter Senge. Yeah. Anybody else briefly on this topic? Okay. Hopefully it's making sense. Yeah, maybe quickly, we have a question here. Rama, do you want to help people with this one?
So we'd like to hear from you. How can holistic thinking help in your work, projects, community, or social groups? So you could feel free to pick one of these sticky notes and write your answer here. And simultaneously, once you're done with that, describe unintended consequences in your own words on the side of the board. We'll take about 2 minutes to do this, and we'll have music for the background. If there's anybody who's new to the board, you could type your answers in the chat box.
Yeah, maybe we just take the first one first.
First, okay.
Yeah. I'll just put a couple of minutes at a time.
Great, thank you so much. I'm going to read out the sticky notes that I see here. So we have the right solution can have unintended consequences. And then we have, you make relationships and connections part of the sense making before solutions and activities. By looking at things holistically, you might identify new opportunities and areas of activity or interventions. That's so true. That's an interesting answer. And then it helps to see the contribution of each part to change the initiative. And then it helps being empathetic. It helps seeing the bigger picture, and it might see relationships that have not been considered before. And lastly, it's the dance between balancing competing needs and trying to forecast the unintended consequences. So this is what we see members here would like to use in their word. Yes, John.
Yeah, just to pick up on Valentina's question in the chat. Yeah, totally. That's what it's all about, Valentina. Seeing both, really, right? So a system is a set of parts, and then interrelationships between them, through which they form a whole that exists and performs a function within some environment. And we're trying to get that view of the whole and the parts, right? So that's what systems thinking is ultimately arguing for, that we need both. There's a lot of benefits to reductionism, analytical reductionism, and we see that all around us in our world. What we've done with healthcare, what we've done with chemicals, like how we managed to create all these fabrics, our clothes, and so forth. That was through people staring down microscopes and looking at atoms and figuring out how to combine molecules in new ways. And we can see then all around us the benefits of analytical reductionism and also the failures of it. But holism has its benefits, right? It helps us see the whole, it helps us see the interrelationships, it helps us understand the purpose of the overall system, helps us understand the system within the context of its environment and relationship with other systems. But it too has its failings, right? If we take an overly holistic approach, we lose sight of the parts, right? What reductionism is so good at, what analysis is so good at, is really understanding deeply the parts. But holism is really bad at that, right? Holism is this kind of big picture view where you step back and see the whole, but you don't understand parts and the details, and that can create a lot of problems, right? If you go into project management without ever looking at the details, you're going to create problems for yourself at certain stages. That's just an example. So it's all about this balance between the whole and the parts, or how the parts interrelate to the whole. But as Mike was saying, or others were saying, most important thing is awareness around all of this, that we're aware of how we're looking. Are we taking this reductionist approach, or are we taking this more holistic approach? Arwen?
Yeah, no, just because when you're saying like reductionism, I mean, and we're looking at the parts, but they're subsystems, aren't they? So if you're looking at a bicycle, you could also look at the saddle. And what's the saddle for, and what are the parts of the saddle? You can also look at the bicycle and see it as a part of a system for health, or part of a system for getting around, or part of a system for cluttering up your garage, or whatever it might be. So I think maybe it's a question of taking responsibility for what level we're looking at, because everything's made of different, even we're made of cells, we're part of other things. So I think it's not exactly a binary, is it? They're different levels in the system that we're looking at.
Yeah, they're different levels, and it's relative. But what reductionism is really doing is it's a mode of inquiry into the world. And when you adopt that mode of inquiry, what you do is you break things down. So it doesn't matter really where you start. As you say, everything's like very relative. Are you looking at the universe here, or are you looking at atoms, or everything in between? But as a mode of inquiry, what actually reductionism does is it isolates a system. So if you see in modern science, a lot of what we do is we take things out of the context, out of the world. If we want to understand a bird, we bring it into the lab, and we don't put it out there in the world. We put it in the lab and we dissect it, and we look at all the parts to it, and we think by understanding its anatomy we can understand the bird. And that's reductionism. It's a mode of inquiry. But holism would say, wait a second, you're wrong. The most important thing about a bird is that it goes out there in the world and it interacts with others. That's why its beak is this long, because it interacts with that plant and has to get that nectar down there, and it has to escape that animal, and it has to, do all these things. And that's the most important thing. So we need to look upwards, right? So it's not about, necessarily parts and whole, I guess. It's more about which direction are we looking? Like, what's the mode of inquiry here, and how can we balance the two? Okay, great. Let's dig on then. So yeah, both have had their advantages and disadvantages. One of the problems with analytical reductionism is you do this stuff, you break things down. And what happens when you break things down is you separate them out. And that's good for getting narrowly more specific on things and really defining things. But actually what you do at the same time is you create lots of dichotomies, it's a binary way of looking at the world. And you get a lot of this thinking that goes either or. We should do this or we should do that. It's this or that. It can't be both. It must be, we must go this way or we must go that way. And that works fine in simple environments where there's a clear, well-defined structure. There's a right answer and there's a wrong answer, right? The weight of this pen, there is a right answer and there is a wrong answer to that question, because it's a relatively simple, objective thing. Many other things, like how to raise children, there is no right or wrong answer to that. It's not a binary kind of decision like that. And systems thinking helps us see the multiplicity of different options, and think about how to adapt and respond to different scenarios. So it's more of this kind of spectrum view that helps us see the whole as an integrated thing rather than dividing it up like this. Again, both have their place in the world, but it's important for us to understand how this type of thinking is shaping our view of the world, and then how we go about trying to manage it and design it and, do all these things, because it leads us down pathways. So that's that. And, systems thinking is going to help us better deal with complexity. And that's because when systems become complex, they become highly interconnected. And complex systems have many parts, many interrelationships and interdependencies, and many pathways through which effects travel in that broader network. And if you narrow down and focus on one part, you're going to get very smart and very intelligent about that one part, but there's so many other things here that you're not looking at, and you are context within which it exists, and very likely you're not going to get the results that you want. You're going to get unintended consequences, because almost by definition, when you narrow down and focus in a complex system on one part, you're going to create unintended consequences because it's so affecting everything else. When you do something here, it doesn't just disappear. Now that this thing is highly interconnected, it starts to affect this, and that affects that, and that affects that. And it may take time, but that comes back to affect that, and you get this feedback loop that affects where you started, and an unintended consequence arises. And that can take time, but they're there. These effects don't just disappear in complex systems. Things are interconnected and interdependent. And systems thinking is going to help us step back, as we talked about, and see, okay, I'm not just going to analyze this thing here. How is it related to that and that and that and that, generally, so that I'm not going to do something really, lacking in intelligence that's going to affect this, that's affecting that, that's going to lead to these unintended consequences. And as our world becomes more complex and the systems we have to interact with and design, manage, try and innovate in become more complex, we need to be able to do this stepping back systems thinking stuff. We can't fully understand the system, we never will, but we can get this broader pattern view of it, so that we've become more intuitive about what are the right actions, what's going to actually generally affect what, and how that might come back to affect us, and that can inform what we should and shouldn't do. So that's that. The Cabreras, they say wicked problems result from the mismatch between how real world systems work and how we think they work. And systems thinking tries to, resolve this mismatch, because we often bring a lot of linear thinking. We'll talk about that in a minute, to our understanding of the world and our way of approaching change and so forth. And we don't see all these feedback loops, and there's a big gap between these people sitting in their boardroom meeting looking at this pie chart or this bar chart, and this reality of the economy, the global economy that they're interacting with, which is vastly complex, and all these networks and so forth. And Cabreras is saying we have so many problems in the world because of this complexity gap, right? We have this gap between the way we're individually and in our organizations and society on a political level thinking about the world and all this complexity out there, and our models, which is so kind of linear and relatively simple. And we need to bridge that gap. We need to expand our understanding, particularly if we're in the business of innovating in systems. If we want to just change, design a new pen, that's maybe not such a big problem. But if we want to change transport systems, healthcare systems, and so forth, we need to be careful and considerate about doing that, because it affects many things. And there's much better ways to innovate in these systems than linear thinking would lead us to believe. So this kind of thinking is going to unlock huge potential for us when it comes to innovating systems. It's also going to be a responsible and careful way to go about doing this. Otherwise, we're going to create a lot more unintended consequences. Okay, yeah, you had a question. They already started answering it. Roma, do you want to...
Yeah, so we have a follow-up question from there. Describe unintended consequences in your own words. So you could write your answers on the sticky notes or put it in the chat box, and keep a timer for about 2 minutes. Great, thank you so much. I'm going to read out a couple of stickies and then we will move on to the next part. So we have some of the answers which says downstream ripple effects, and then solving one thing may cause overload damage to other parts of the system, which is electrification. And then the action of those in power with zero accountability towards others. All right. And then results that happen even though they were not planned or expected. Yep. And then people often the most vulnerable falling through the gaps in a system. Example, social benefits. And then effects far away in sector, geography, or time, which happen because of our actions. Example, biodiversity loss because of genetic improvement of crops. Yep. And then unexpected output are a series of reaction. Critical time is lost in dealing with complex issues while still writing. And then short-term whipsaw solutions can sometimes not deal with the real challenges, cognitive limitations. And then we have many more answers. Joss, you want to say anything about this?
Yeah, I'll just pick up on Jim, you put in the chat there, cognitive limitations, which is a good one. We have individual cognitive limitations, don't we? And that's why systems thinking is a team sport. Understanding complexity is a team sport. We can't understand a complex system alone. But if we can create frameworks and ways to integrate our different perspectives on that, then collectively we can build a better understanding of it. So systems thinking is a team sport. You just being a systems thinker in an organization where everyone's a reductionist thinker is not going to help massively. Can we get teams which are actually thinking like this and then recognizing the need for a perspective that we can't understand a complex system? We do have cognitive limitations individually, but we're not just alone. We can, when we value and recognize different perspectives and the need for them, then we can find ways to integrate those and, turn this into a team sport. And that's the only way you can understand a complex system. A simple system like my pen, there is an expert who can understand the pen and the weight of the pen and so forth. A complex system like the global economy, no one really understands it. It benefits from the synthesis of many different perspectives. Okay, let's dig up. So moving on, that was all about reductionism and holism. It's foundational. Their paradigms and well-views. This section is going to talk a bit about emergence as a very core idea. So this is Brian Arthur, a complexity researcher at the Santa Fe Institute. And he says, with complexity, you're always trying to see how small parts, like starlings in a flock, come together to create what is happening in the economy. He's an economist. Each individual starling is only reacting to its neighbor, and yet all those reactions are somehow summing up to give the flock as a whole. And the flock, when we see those murmurations of starlings, those beautiful flocking of starlings, we know that it's not a random thing, right? They have these beautiful movements in coordination. But he's saying that's not a master plan being imposed by one of the starlings on the rest of them. That's this emergence thing, this bottom-up interaction between all the birds, guided by certain rules about flying in a particular direction according to their neighbor and staying a certain distance and so forth. And out of that, we get the emergence of beautiful flocking. So that is actually a different way of looking at the world than we're used to, right? We're used to this reductionist way where we say, if there is a order in the world, that's been imposed in a top-down way somehow. So we talk about organizations, we assume there's a boss and, you're going to have to manage the whole thing. We're going to, most of our organizations look like that. And most of our engineered systems and so forth look like this, project management and so forth. And, but in the world, there are other things. There are systems like those flocks of birds that manage to create order without one of these, without a boss. And that's interesting. And it's not something we normally focus on so much. We focus a lot on this kind of how are we going to get order around here, right? We're going to need the president, he's going to need some ministers, and then there's going to be departments, and they're all going to run around doing what the minister says, and so forth. Well, there's other ways as we store with that flock of birds, right? In many situations, like traffic jams, like people crossing a street, like markets, unregulated markets, and so forth, they can self-organize in certain ways based upon the peer interactions between the elements. We call this self-organization, and it leads to what we call emergence. Actually, the growth of the human body or any biological system is an emergent process in some sense, because the cells, as they grow, they're reacting to other cells beside them as to what sort of cells they should become. And out of that, we're getting this, amazing biological organism. And the classic example of emergence is consciousness, right? Which is, to me and you, it makes sense because we're human beings and we've been conscious most of our life, hopefully. But imagine if you went to a universe, if all you knew was a universe of atoms and molecules, and someone said, out of all these random atoms and molecules, we're somehow going to get a human being, and that human being is going to have consciousness, and they're going to become aware of the world, and they're going to write poetry and all of this. You'd be like, that is way too way too wild. How could we possibly get something like that? Yet we do. And that is emergence, all these parts coming together like a plant, a living system, right? All it is carbon molecules and atoms somehow come together in the right way to give us the emergence of life. And often we don't see the world, we don't look at the world in that way, right? So in biology, even though it's the study of life, generally biologists, they stare down microscopes and they chop things up, they take them apart, and in so doing, they remove the most important thing, that it's alive. And if you looked at this biology thing in a totally different way and said, wait a second, we're not going to chop things up, we're not going to divide them. Let's think about how does life actually emerge out of, we put these parts together and suddenly we get a living thing. That's pretty amazing. Like, what's going on there? How does that happen? That's emergence. It's a different way of looking. It's this synthetic way of looking at the world. But we could equally do that for everything, right? We could say, okay, we have an organization and we organize it like this. And yeah, we get that. We see a lot of these things around us. Could we do it differently? Could we do it with this emergence thing? Is there a way we could develop a platform and infrastructure to support people to organize in the right way, in a kind of a networked way, to start self-organizing and so forth? That's a different way of looking at the world. And you could apply that in any context, because this is about how do we get order in the universe, in the world? How do we create that? And too often we're looking like this. We're assuming that there has to be this plan imposed, right? But we could, and quite often there does, right? Particularly for very basic things. But sometimes in very complex systems, we can't actually impose order like that, right? We see it all around us. We're trying to, control things that we can't really control, and we need to learn a different way of working with very complex systems. That's more like this, right? No one really controls the global financial system or global supply chains or the global ecosystem, and we need to find a different way of relating and working to them in all the complex systems that we want to innovate in and adapt and change. Healthcare systems, right? They're so complex that there's not really one actor in control there. And we need to move away from a lot of what we're doing, like governments. The next healthcare minister comes into the UK and says, yeah, we're going to change the NHS and we've got a plan and we're going to fix the whole thing. And we see a lot of that and it doesn't really work. Is there another way, this kind of self-organizing, bottom-up, emergent way, creating the right context for the actors to behave and interact in the right way to get the emergence of the beneficial outcomes that we want? And that's a different way of innovating, different way of approaching management and change and design and so forth. But it's what's being encouraged here. Again, it's not one or the other. It's looking at the system. Is this a simple system in which we can apply this kind of reductionist control logic? Or is it a complex system which we can't control, right? A complex system is like your child. Right? You're not going to plan out the rest of their life for them. You're not going to control the rest of their life. You've got to work with them as they adapt, as they grow, as they try to find their way forwards, and you try and create the right context for them to figure out who they are, what they want to do, and develop and grow, and so forth. And that's a bit more like this side, or a children's party as an example, right? You don't want to try and control and predict everything in a children's party. You want to set the right context and invite the right children and put in, the food and the playground and all of this, and just let them play and see what happens. And if good things come out of it, try and amplify those. If they're doing really bad things, try and dampen them down, set boundaries, right? Definitely you can't go to the neighbor's, garden and so forth. You can't set that on fire. Those are boundaries you definitely can't do. But within this context, you guys should be able to interact and figure out how to have fun here in your party and so forth. It's a different way of looking at the world. It's a different way of approaching change and so forth. But it's this systems approach or emergent approach. Does this make sense to people, this idea of emergence? Are you familiar with it already? On a scale of 1 to 10, maybe put in the chat, are you getting this idea and how it's kind of a different approach and not very intuitive to us? 10 is this really makes a lot of sense. 0 is I'm totally lost. What are you talking about? Okay. Mark?
Yeah, just just reminded me of Cynthia Kurtz. She talks about organization and self-organization. Is that what you would see a relationship it
Yeah.
related to?
Yeah. I mean, there's a lot around self-organization in organizations. That's it exactly. Yeah. Self-organization is the process through which you get emergence. Emergence is kind of the outcome. Yeah. Okay. Yeah, I mean, there's a lot to this idea of emergence. It's really core to systems thinking because if it wasn't for this idea of emergence, then this reductionist stuff would work fine because the whole idea of emergence is that the whole is different from the sum of the parts, right? So you put two things together, like us, you put all these cells together in our bodies or these molecules, somehow you get a human being that walks around and eats and makes poetry and all of this. That's an unconscious, right? That's different from the sum of the parts. If everything was the same as the sum of its parts, we could just take it all apart and do this reductionist. But here in systems thinking, we're saying actually, you put these things together in the right way, and ping, you get light. But if you take them apart, you're going to lose that. And we need to think about these emergent overall patterns that form. Okay, great. Yeah, there is a lot to this. It's a very big, deep kind of concept, emergence, right? It's been with us for a very long time, so I don't expect you to understand all of it right now. But hopefully, you're getting the general idea and how it's relevant here. Barney?
Yeah, I was just wondering because I have been in service design Berlin, and they were no more talking about the users of both internal users and external users, like customers, of course. And how do you connect this to systems thinking? Wouldn't the hierarchy be the organizational structure and the emergence, the users, both inside and outside the organization?
Yeah. So imagine you've got your organization here, right? And it's all structured like this, but then that
Yeah.
organization creates so take an example of Uber as the car company. So Uber, the company, is organized like this, right? The core of it. But what do? They create a platform that allows drivers to get in their car and drive other people around and choose where they want to drive and so forth. They're actually creating an infrastructure for others to go and co-create that with them. Or the transport authority in your city is maybe a platform, could be a platform to support the optimal organization of the city. Although me and you are choosing which modes of transport to take and cars and so forth, they could see themselves as a platform that's supporting that self-organizing kind of processes. But yes, that's true. Yep. Okay,
Yeah,
let's return.
like platform design. Some in the industry are talking about platform design.
Yep, that's it. Exactly.
Yeah.
So platforms, the context, isn't it? It provides the infrastructure that then other people are going to do things on top of. And that's creating the context. Systems thinking helps us work with context. The children's party, what I was talking about is creating the context, right? The playground for them to play in and so forth. Not trying to tell them all what to do or own them or manage them or whatever. So systems thinking is about working with context and finding ways to manage that influence the context. Danielle?
Yeah, it reminds me a little bit of what Henry Mintzberg has shared about, he's saying, we think about organizations sometimes like a cow, and a cow like in a butcher shop window that has actually all the different cuts. And instead, we shouldn't be thinking about that because, you don't get a sense of the cow by looking at the different pieces. So he says, think like a farmer, not like a butcher, right? Think about more the holistic sort of thing rather than actually in the different pieces that comprise, that cow.
Exactly. So it goes back here, like this thing of the difference between, so the butcher just has the cow and wants to chop it up and turn it into, beef burgers, right? But the farmers got to think about, well, this cow needs food, it needs to go out into the field and it needs water and it's interacting with its environment and so forth. So again, it's a bit like the difference between, say, an architect and an engineer, right? So an engineer has to worry about the details of let me see, like laying the floor or something, or the structure. The architect has to think about the whole building. Like, how's this whole thing? Is this a livable space, right? A person's going to come in the door and they're going to want light. They're going to want a sink full of water. They're going to want a bed and so forth. So again, it's a different kind of perspective, and different roles will need different functions. And again, it goes back to systems thinking as a team sport. We need all them working together, right? Not just the architect, not just the engineer, but everybody working together. Yeah. Okay. So quick question, Rama, should we go on?
Sure, Joss.
Yeah, let's take one of these.
So we'd like to know, how would you explain the concept of emergence? And you could write in on one of these sticky notes any examples, any experiences, any ideas. So we'll start the timer for 2 minutes.
Yeah, do you want to take a look, Rama? You're on mute. You're on mute, Rama, if you're talking.
Okay, I'm sorry for that delay. Small technical issue here, but we're good now. So we have some interesting answers, which I'll just read out loud. We have emergence is the thing that happens when parts of a system come together that could not happen when part is acting by itself. And then it's almost magic. Nice. And then emergence is fluid, responsive action to what is needed. Then we have the emergence is the properties. The properties are different from its parts. Like a cake is not the same as flour, eggs, sugar, etc. Knowing something about eggs tells you little about cake. And then deconstructing the part to rebuild organically and for purpose. And then we have emergences patterns that appear when the system is given the freedom to self-organize. Yes. And then organic and independent. And then we have emergence is connections that emerge around us in everyday life. It's the patterns and outcomes are unknown and unpredictable and only emerge once you engage the system.
Really, maybe Sigga, but I'll just pick up on a couple. I mean, this one about the cake, like it's a cake's a recipe, right? And what's interesting about that is the cake is nothing. What's the difference between the cake and all its parts or its ingredients is the recipe. And what's the recipe is just a way of putting those parts together. And you have a process for putting them together, the cookie and the cake. And then out of that emerges a cake, right? So what we're getting at is this emergence thing is just about the organization of the parts, right? We're not adding any more parts or anything. It's just a different pattern of organization that grew, that developed over through a process. And that's very interesting because it's going to tell us things about how to approach systems innovation and systems change. So maybe we don't need more parts. Maybe we don't need to change the parts in a system so much. If we want to change that system, maybe we need to think about how they're organizing. And the thing about a cake is, if I tried to create a cake, it would be pretty bad because I don't know how to create cakes. I would put the ingredients together in the wrong way, the wrong ingredients in the wrong way, the wrong amount, and cook them in the wrong way, and you get a terrible cake. So it's actually all about this relationship between the parts. The synergies between the parts is what creates emergence. So that means if we want to get emergence, right? If we go back to the context of systems innovation, we're trying to transform systems, we're trying to get the emergence of new outcomes. We actually need to figure out how to put these parts together in a new way. Like that should be our core kind of focus. And it requires a lot of relational thinking. Maybe I'll just jump here first whilst I'm on context. So relational thinking is another big part of systems thinking because we understand a system is just these parts and how they're put together into the whole to give the emergence of a functioning whole. So reductionism doesn't, what reductionism does is break things down and it removes the relationships and it removes emergence, or the non-linear relationships is really what it removes. So when we try to put them together and we focus on the synergies between the parts and the emergence, then we start to say, okay, let's focus on these relationships, this network pattern, and how something new is emerging out of that. And that's core to systems thinking. It's called a systems change because as we go about trying to change systems, what we're trying to do is, change negative synergies to positive ones so that they're working synergistically instead of, against each other. And then we'll get the emergence of something beneficial. So this relational view of the world is very, very important, and it's shifting away from a disconnected view to thinking about networks and relationships. And that again is a paradigm shift. We often look at the world in this way. Social services are based upon a lot of data about people, their age and their gender and their ethnicity and so forth. How much are they based upon their social network? They're not really. We don't really understand social networks. We don't really look at the world in that way. But of course, you are almost, what defines you and your quality of life and your income and knowledge and all these things is as much about you as it is about your social network, right? Who did you grow up with? What was the neighborhood like? Who are you working with? So on and so forth. Who are you connected with? Who are you not connected with? So it's not just what you know, it's also who you know. And quite often we focus too much on this view of the world because the parts are very concrete things that we can see and we can touch, whereas relationships are more abstract and difficult to see. So this is what systems thinking is encouraging us, not just look at the parts, but think about this relationships between them, and networks of relationships, and the structure of those relationships, and where you are in the network, and how things flow through the network. And it gets to network science and network theory that helps us understand networks. And that is a different way of looking at the world, right? We're often looking at the world like this, but that tells us nothing about relationships, right? This view of the world. This view of the world tells us about relationships. And if we want to change systems, we really need to start looking like this, at the relationships and the synergies or negative synergies and the overall structure of that network. Is it centralized? Is it decentralized? How, if I change something here, will that easily affect all the others? Because this is a very influential node. Or is this person not connected to anyone else? You know, we see a whole new ways of doing marketing, whole new ways of doing organizational change, which is based upon influencers and key people in the organization who are, you know, well connected and can influence many other people, even though they're not the CEO or something like this. They are key people through which many other people are connected, and they can have a high influence and so forth. It's a different way of looking at the world, and it's key to doing systems innovation. So I just wanted to jump there so as to help you think about this relational view of the world. And Harold Nelson, systems thinking starts when you switch from looking at something to looking between things, and how things are connected, and even the quality of the relationships between things. We don't talk about that so much. We're always so often trying to improve the parts. Systems thinking looks at relationships rather than unrelated objects, connectedness, process rather than structure, the whole rather than just the parts, the patterns rather than the content of a system and context. Systems thinking systemically also requires several shifts in perception, which lead in turn to different ways of teaching and different ways of organizing society. Different ways of look. This was quite revolutionary, right? When you change your thinking like this, it can lead to huge downstream effects. That's why we start here on systems innovation, because it's the bottom of the iceberg. New ways of looking at the world can really lead to different ways of organizing, different ways of relating, different ways of doing things. And that's what we're hoping for here. So it's really the only way we're going to get a very transformative and systems level change. So yeah, I want to get to our little workshop. So I'm just going to kind of wrap up on these points. The other one's around non-linearity. So maybe if you know about systems thinking, you've seen these feedback loops, systems dynamics. And a reductionist view of the world often sees it in terms of linear causality. A causes B, but it forgets that B may then feed back to affect A. And indeed, it often does. And it may not just be direct like that. It might be mediated through a few loops, but we get this feedback loop that creates interdependency rather than independence here. So often we're trying to go about addressing challenges through this cause and effect thinking. And we analyze the system, find the problem, and what are the causes of that problem. And if we change those causes, we'll fix the problem, and that's it. When wicked complex problems are more like big messes like this, and they emerge out of all these interacting factors and contexts and relationships with many other things. So we need to be looking at this relationally. We need to be looking at it in terms of emergence. We need to be looking at it holistically, but we also need to be thinking about these non-linear dynamics, that it's not one or two things affecting this, it's the broader context that's affecting it. That over here, like a plant, a living system, like a child. It takes a village to raise a child, right? You can't just raise a child yourself and hope that that'll be super successful. You need many other things in relation to that. And out of that, you'll get the emergence of, a child who has the right context needed to develop and grow. So that's non-linear thinking, non-linear way. It's a networked way of looking at the world. That this problem emerges out of multiple different factors and the context. And we need to change the context if we want to address the challenge, not narrow down to a particular cause that's going to fix it, but expand out and say, what's the broader context? How can we influence that to get the emergence of the beneficial context for this system, but for the emergence of the beneficial outcomes? Yeah, so a little bit rushed there, but I wanted to move to our workshop. Wanted to quote, systems thinking means the ability to see the synergies of the whole rather than just the separate elements of the system, and to learn to reinforce or change whole system patterns. And you can see that's getting to this idea of systems change. We're not just going to improve one of the parts. We're going to start to try and see the system and start to work with relationships and patterns. And then we're going to start to get this ability for systems change. Okay, let's take a little bit of time for our workshop. Should we, Roma? Any questions or comments on this so far? We're going to go into some exercise based upon those ideas. How we doing? We're learning about some big ideas here. Any questions or comments so far? How are you following along on a scale of 1 to 10? Mike, yeah.
Yeah, one thing when I was learning about emergence, which took me quite a while to get my head around really, was that the perspective you come from when you're looking at the emergence a system is creating, then kind of defines the way that you would interact with a system. And it took me quite a while to get my head around that, because I was always kind of looking at, rather than I was kind of looking at the system first to go, what's the primary emergence that's happening? And then I kind of just default to kind of what the biggest things seem to be.
Yeah.
And then as I got more into like thinking about emergence, it was more about kind of, oh, what's the emergence that I feel is positive or negative that I want to work with that system to change. So I suppose perspective is massively important. I mean, that's like my comment on the cake is like a cake can, the emergence can be the joy of eating it, the guilt from eating it, or the fact that it smells nice, or it makes your children happy, or it can just be the fact that you've made a cake. The cake as a whole looks aesthetically pleasing. So there's like all these different things that a cake, the emergence of a cake can be. Yeah, I just wanted to say that because I remember when I first started learning, I got really stuck on like, oh, there's just one emergence here of this system. But yeah, I'm not sure if it's helpful to everyone else. That was just something that really stuck with me when.
Yeah, it does take a long time to change to this, just to get the idea and then to change this perspective. But I think initially what you're getting at there was, it really is a paradigm shift. This difference between seeing a problem where there are causes of that problem and you can fix that problem by changing the causes, and you're narrowing down on that to actually step back and look at the system and say this is emerging out of the broader system, and I need to work with and influence that broader system to realize the emergence of beneficial outcomes, different outcomes. And that kind of takes time to get there. Of course, this thinking on the left, the linear thinking, can be successful in simpler systems. And it's really when we're dealing with complexity that we need to really embrace this emergence idea on the right-hand side here. Okay, maybe I hand it over to you, Roma. We've got a bit of an activity for you people.
Thank you, Joss. So we have a little workshop for us, and we have sent the challenge right in the center, like how How might we redesign our societies to be more inclusive and resilient? So that's the
Cities.
challenge.
Cities, yeah.
Yeah, redesign our cities. Sorry. So that's the challenge. And then we will start from the left corner, whole and partial. So over here, you can add stickies and write what it looks like to see the system as simply a set of parts versus what it looks like to see the system on the macro level. How do we describe this? So we answer these, and then we look at what does it look like to see the system in a linear fashion versus how do small parts come together in a bottom-up way to form new emergent patterns. So let's take about 5 minutes to answer these questions, and the time starts now.
Yes, so the exercise is really about helping you look through these different perspectives, right? So that you understand what it means to look from one view or the other.
Let's start writing in the linear and emergent quadrant. It's already written in the first quadrant. Great. Thank you so much. I see some really interesting answers. Josh, should I read them out or we move on to the next part?
Yeah, I think we have a little bit of time. Yeah, just a minute or two.
Okay, sounds good. So for the first quadrant, partial and whole, I'll start by reading the partial. What does it look like to see the system as simply a set of parts? Looks like individual services, functional districts, e-shopping center district, focusing on individual elements like roads, hospitals, services, and then not recognizing the connection between active transportation and health, for example. So these are some of the partial examples. And then for whole, combine traffic flows and then design for all needs in 10-mile radius, yes, and then access to housing and public transport, use an ecosystem lens, agglomerations of living entities, and then a city of diverse villages. So this is what it looks like when you look at the system as a whole. Moving on to linear and emergent. For the linear, we have vehicles and logistics, a tube map, a hospital. Think about in terms of residents, infrastructure, governance, etc., all operating separately. And then in the emergent approach, high crime, okay, there's high crime rate, social prescribing, community care, social shared responsibility, community gardening, building social connections and assisting lonely seniors for those with dementia. And then we have another answer in a language I'm unable to identify. But so this is what we hear from you all. Joss, you want to say something about the answers?
No, let's stay going. We'll take another 5 minutes. We have a bit of time, shall we? Yeah. Do you want to explain here?
Perfect. Yes. So, for the bottom two quadrants, we have 5 minutes. On the right side, we see what does it look like to see the system more disconnected, more from a disconnected perspective, versus how can we look at the system as a network of interacting parts. So, and then on the left side quadrant, towards the end, what does it look like to see the system's development as predictable and planned, versus what does it look like to see from the perspective of adaptive capacity and evolution? So we could take 5 minutes to fill in our answers. Thank you so much. I'll read some of the sticky notes over here. Between disconnected and networked way of looking at system. For the disconnected way of looking at system, the examples on the sticky notes are segregation, class systems, and then not app and maps, and then private, local government, NGOs, and the public. Each component exists by itself. And then taking systems like healthcare benefits, education, and attempting to reform them in isolation. And then NIM, leading to socially stratified neighborhoods and urban sprawl. So this is what disconnected way of looking. And then network approach is nearest bike hire, understanding the relationship between health, poverty, education, etc. And then close cooperation of city districts, municipal governments, and then community hubs and peer-to-peer networks, government, residents, regulations, legislations, urbanization are dynamic entities that interact with each other. So that's right, network way of looking at things. And then moving on to the last quadrant, we have planned way of looking as if the system development as predictable and planned. For that section, we have planning, dispatch, and packaging vehicles, flexibility planning, routes, and optimize, and then believing cities will develop as expected without adapting to uncertainty or change, and then introducing more bike paths. Predefined infra development, long-term planning is not responsive to actual demand conditions, yes. And then for the adaptive, linking local policy to national policies, multi-purpose third spaces, multi-purpose buildings and parks. Cities are expected to grow with migration, building flexibility, and room for growth into systems, digital ecosystem logistics for delivery and transportation. And lastly, taking a longer time horizon beyond election terms and recognizing connections between social determinants of health. So these are some of the interesting answers that we see here. I think we are towards the end and I'll be wrapping up. Is that okay, Joss?
Yep, go for it. Yeah, well done, everyone. Maybe just a quick recap before we go there, Roma, just to say what we covered today. Hopefully you're getting a sense of systems thinking and what it's all about and some of these key dimensions that are going to help you shift your thinking from this more partial to this more holistic, from reductionism to emergence, disconnected, connected, linear to non-linear. These are some of the dimensions. They're all kind of looking at the same thing, which is ultimately trying to help us not just focus on the problem, on the part and the immediate solution to that, but stepping back and looking at and learning to work with the complexity of the broader system is what these ideas, what this approach is going to help us with. And from this is really the ideas and the thinking and the awareness that we need to then go about, mapping out the system, which we'll be looking at in a couple of weeks, finding intervention points, trying to intervene, trying to bring actors together to collaborate and change that system in a responsible and productive way, and trying to avoid these unintended consequences and really have that capacity for a more transformative systems level change. Great, I'll leave it there for now.
Thank you so much, Joss. And we are now wrapping up. So for the next session, we have a learning series meetup next week, which is March 25th, and it's going to be online for about 30 minutes. So if you're on your pathway to certification, it would be great to have read some of these concepts and have watched videos already. And then we could meet up for the learning series meetup and unpack some of the concepts we have discussed today. And then our next event is systems mapping on 1st of April, where we will talk about this third module called systems mapping. And now towards the end, we'd like to hear your feedback. Feel free to let us know how do you feel about today's session between 0 and 10 on the horizontal bar, 10 being I found it extremely relevant and engaging. So we have dots on this in this panel over here. So you could take any color and place it on the horizontal bar. And if you have any feedback for us, any way we could improve, you could leave us a comment on one of these sticky notes. We take your feedback really seriously and work on it. So thank you, everybody. Thank you for joining today. And if you have joined today, would recommend that you join for the rest of the sessions as well and complete the journey with us. And thank you so much again, and have a great rest of the day.
Excellent. Thanks, Roma. Good to see you guys, and hope to see you next time. Yeah, take care.